Oh, I see what's happening here.
Recently been taking this course called machine learning, mathematics for machine learning. It's like one of 3 courses. The first one is linear algebra, learning about matrices.
Okay. Why is it not sharing?
Where
Oh, you're sharing the Jitsi share.
Coursera?
Yeah, I can switch tabs.
Yes, switch to something.
There you go. They'll give you confidence.
Yeah, they have a
Okay, cool.
meeting now to watch the lecture.
Look, the problem isn't like finding like what you need to learn.
Okay.
Well, decide what you want to learn.
We're streaming. Go ahead, take it away.
Are we doing any introductions or just jumping in?
There's way too many people.
Cool.
You can introduce yourself.
I will. I definitely will.
Let's scratch the surface.
So we good?
He's the man now.
We're good.
Are you in charge?
Are you in charge
of
of
the
the
meetup now?
Welcome everybody to the Blvd. Glad you're all here, and we're gonna have this awesome presentation by Elaine. Starting next month, we're going back to second Thursdays for our meetings, and since I am ostensibly running the thing, I'm gonna start each meeting with a little like new presentation about some little topic for like 5 or 10 minutes, and then we'll have something a little bit more intermediate-ish, and then we'll have like the second hour is just going to be consistently just chatting and stuff. So that's sort of going to be the format from here going on. If somebody else would like to do the first 5-10 minutes, just let me know. You can volunteer. That's fine. Otherwise, I'll just do it. But next time, I've got it all prepped out and ready and stuff. But I was actually going to do it this time, but I was way late, so forget it. Let's have Lane do his stuff. All right, go ahead and introduce yourself and let's take it away.
Cool. Yeah. So I'm Lane. I'm the founder of Blvd. It's a platform for learning backend development. And primarily, we teach Python and Go. So I've been interested in Rust for a while. I don't really know what I'm doing, but about a year ago, I integrated Rust into our engine. So all the courses on Blvd are interactive. You write code, you get feedback on your code. There's kind of a Replit experience. And I introduced Rust in kind of this like REPL system. Like I said, about a year ago, and it broke because it depended on the night we built. And the feature that it depended on was ripped out. So about 3 months later, everything stopped working, and I had to just take it down. In the last month, I rebuilt it, not using the build. So we're going to go over how it works and everything. So the 2 links that are going to be interesting, if you want to follow along, are boot.dev/playground/rs. So that's going to be the live playground that's hosted on boot.dev with all the fancy syntax and everything. But basically what it is just a REPL, right? We can write Lane. And the trickiest part about getting this whole thing to work was working with macros, because if you've done anything with Rust in WebAssembly before, println does not work out of the box. So we'll be taking a look at how we got that to work. But the interesting thing about this Rust playground is that it's fully running in WebAssembly. So what happens is when you click the run button, the code that you've written in the browser is shipped off to the backend server, where it's compiled to a WebAssembly bundle. It's shipped back to your browser and runs in a web worker. So I'm going to go over that.
So actually, it's compiled on the server side, but it's run in your browser.
Right. Yeah, specifically in a web worker, which has been really nice for example, students writing like infinite loops and not having their browser locked. So there's
not familiar with what's a web worker.
Yeah, so web worker, you can kind of think about it as a separate thread that your browser will give you to write JavaScript code that you can run kind of in the background in another worker, right? So if something goes wrong in that worker, for example, if it's caught in an infinite for loop, for example, you can kill that worker. Normally, what would happen is the browser would just freeze up. Yeah.
So is it just basically just capturing like STD out or something?
I wish it was that easy. That's how the Go works. I basically capture because we also do Go and it works the same way. What we'll get to in just a minute is basically all the macros get overridden, and that's I tweeted about it earlier today. It's macros all the way down. There's a lot of macros in here. But at the end of the day, we're kind of capturing. I think it's the my ignorance is going to show I'm really not good at Rust. Like the core writer. Does that sound like a thing? It's a thing. There's a writer down there that we're grabbing from some standard library.
Do all the macros slow down the performance at all?
Compile time, I guess. But it's not. Not really. I mean, you can see this time it takes to run. I mean, this is 2 network calls, right? Well, 1 network call back to my backend server. It's running in GCP, so it's pretty quick. It's not too bad. But I have published a much simpler version of the whole stack on GitHub, so that if you're interested, you can pull it down and look at the bits and pieces. So that's on github.com/wags/rust-wasm-play. I think the link is somewhere in the notes for the show. It's in the meetup.
I have a question about that.
Yeah.
Why is 66.6% of the repo in Go?
Yes, because the backend's written in Go. So I did not want to take time to rewrite it in Rust. This is like I took all of the interesting bits out of the production server on Blvd and ripped it down into this repo. But we will be looking at some Rust code. Okay, so from a high level, and please feel free to ask questions. I just want to make sure everyone understands like the architecture we're talking about. We're writing some Rust code in the browser. Right, we are taking that raw text, that string, we're shipping it to the back end, using the Rust compiler, cargo, compile it down to some WebAssembly, and then shipping it back to the front end where we run it. So that's the whole thing. And then we're kind of capturing standard out and standard error and those things, and logging them to this console. So those are the bits and pieces. Okay, let's look at how it works. And I'm going to go ahead and actually run the demo version so we can see how it works. So following the README for this little demo version, first, if you're following along, you can just you just need to make sure you have Rust installed and that you've added the WebAssembly target. After that, you just need to build the binary. So we'll rebuild it and then we'll run it. And then you have to wait a second because it has to create the cargo workspace. So it's basically in my home directory, spinning up a little workspace where we're going to run from within the server code. So you here, where we're going to run cargo build on the backend side. So once it's up, it should be on localhost 5000. /app. Okay, so this is the very minimalistic version of this app, but it's the same. It's the same idea. So whoever was asking about speed, that's a much more realistic look at how long it's taking because we're not making a call out to a remote server. Okay. Please feel free to stop me with questions, even though I probably won't be able to answer them. I'll defer them. That's how to answer them. Okay. So let's look at maybe we start with the client. So how familiar are we with WebAssembly? We want to talk about WebAssembly really quick?
Probably.
Yeah. So WebAssembly is essentially just a different compile target. So normally when you compile Rust code or Go code or any compiled language, you're compiling to a specific architecture and operating system. So Linux, AMD 64, for example. Here we're compiling to WebAssembly, which is basically an assembly language for a virtual machine that browsers implement. So it's a way that we can compile any language. You could compile Go or Rust or theoretically any language that has a compiler that supports WebAssembly. You can compile that code down into WebAssembly and do some nice things with it. It runs a little faster than JavaScript sometimes, in a hand-wavy sort of way it's supposed to. But at the end of the day, that's what we're doing. Okay, so how does this whole thing work? Let's start at the very top. By the way, if anyone has anything we want to stress test in terms of what code we write here, that would be fun. Because again, I'm not very good at Rust, so I don't know what to test. Yeah.
The DDoS attack, that would be really cool.
Yeah.
Just trying to make sure I understand, like, to put the Rust into WebAssembly in order to, like, integrate it with Go and.
So the Go server, you can pretty much forget that it's written in Go. It doesn't actually match. It's just a little API that accepts, like, has an endpoint, so an HTTP handler that accepts as input a string, and then uses cargo. So where was I? Right here. It uses cargo, which is the Rust build system, to build that code into a WebAssembly binary. That's the right term. But we're gonna call it a binary. Yeah.
Rust can, like, translate it, I guess, like, oversimplified way of putting it, but is that what you're saying?
Yeah, the Rust code is being compiled down to WebAssembly. By that, I mean, you could say it's being done by the Go server. It's being triggered by the Go server, right? We're using this is official Rust tooling that we're using to do the build. So you can see right here, I mean, this is something you could run on your local machine, right? Cargo build, target, WebAssembly in release mode. You can just do that on your machine. We're just using Go to do that. So we don't have to manually do it. Cool. So, and then what happens is we're given that, or we get that .wasm file, which is that binary bundle of WebAssembly, and we just ship it back using go.write, right, to just write those raw bytes back to the client in the HTTP response. Cool. So let's take a look at the client side code and see what's going on. So the client's really simple. It's really just a text area that's editable. Right? We'll start with a hello world string. When we click run, this function from the JavaScript is called. So we're also loading this rsclient.js. So this is in web worker world. We're now looking at the code that's running in the main thread. So this is not in the worker yet. Right? And stop me if you have questions about web workers, because they're.
Is that like a browser standard thing, or is it just a concept?
No, it has to be supported by the browser you're using. It's a browser API. Yeah. This is the API specifically. You call this new window.worker, and you give it a path to a JavaScript file.
Relative.
Yeah. Few years. 5.
WebGL demos with. I guess it's not with. Anyway, you can do some pretty crazy 3D stuff with them.
Most browsers should support workers at this point. Any modern one.
That's probably had it forever.
Yeah.
The one problem I've had with web workers was we supported drawing on a canvas in web workers, and Firefox is the only browser that doesn't support that. No, it's fine. Firefox is Safari. So you have to off-screen the canvas. But anyways, it's a window API. In this case, Chrome is supporting it. But basically, we create this new worker object, and we give it the path to the worker file. And then the way the main thread communicates with the worker is through these essentially callbacks. Right. So use worker is going to create that new worker, and when we get messages back, we can, for example, write them to the DOM. So that's how we get our code back. This is just making a call out to that Go API that's running. It's just a simple post request where we're sending that raw string of code. And this is how we are handling WebAssembly. So it's quite literally just binary data. We're just grabbing it out of the array buffer, right? Or parsing it as an array buffer. Cool. Let's look at the worker itself. So this is the client side code that actually runs in the web worker. So if something were to go wrong, again, let's write. I don't think I built a cancel button in the small version, but someone help me out. Yeah, tell me how. What?
LOOP.
Really? That's it?
Infinite loop. That's curly braces.
And that's it for an infinite loop. Okay, cool.
Cool.
Yeah. Let's do this. This will be fun. Okay, so it's just going.
No delay.
It's just chugging. It's a lot of console text.
Scroll bar is tiny.
Yeah.
It's barely moving.
Cool. If we weren't using the web worker, we would have just crashed the browser. Or specifically, right? It would have died. So that's why we're using web. Okay. So let's get to the Rust stuff. The Rust interesting bits. Because and again, if you want to look this up, you can. This is what took the longest when trying to figure out how to build this. When you normally work with, when you're not doing weird meta programming, you're trying to build a Rust playground, and you want to work with Rust and WebAssembly, there are specific ways to log to the console. Right. But obviously that's not cool if you're trying to build a playground. You're trying to write, you want people to write code that they could actually run on their own machine in theory. So this is the first part of the code we'll see that makes that possible. So when you instantiate some WebAssembly that you want to run in a browser, this is the API that you're given. And basically you pass in a chunk of WebAssembly, which this is what we got back from that Go server that did the compiling, and you give it an import object. This import object, these functions, console log, console warn, and console error, are functions that we need to make sure the Rust code knows knows how to use, and we're going to hijack them so that we can then use their output and write that output to the DOM in the browser. See the code. Any questions on that part? It's a little weird. Okay, so we basically just have to make sure that the Rust code we write implements this stuff. And you might be thinking, well, isn't this the Rust code we wrote, right? It doesn't do any of that. Well, we have to write our server to do a bunch of janky stuff on the back end to make it all work. So let's go look at the janky. So this is the glue file. This is where we're defining those three functions that we need to export from our Rust code. So these three functions, log, warn, and error, are, like you said, basically hijacking standards, out, error, and in this case, panic. Excuse me, so that we can capture that output in JavaScript and write it to the DOM. Cool. The function signature here is a little confusing, and this one threw me for a loop for a minute. I'm not going to lie. And let me show you why. So when we get code, or when we get output like back into the JavaScript side of things from the Rust code that's running, we don't get a nice string. That would be super convenient. Instead, we get a pointer to a location in memory. And so this function goes and finds that place and grabs the string out. So that was something that was a little weird, and I was confused for a while until I figured out how to get that working. But yeah, we don't get nice strings back. That would be way too convenient. Okay, so that's how. Any questions on that part? Yes.
So it really does point, and there's no way to like hijack a terminal and just.
There's no terminal in the browser.
There's no terminal in the browser, so it's like
You can extend that JS. The terminal
it's like a terminal emulator. But like
So
you can technically just reflect whatever is in, but then how would it get back and forth?
Let me make sure I understand.
Because you're saying yes, you have to find the string because it doesn't. What we see in the terminal is not.
Well, to be clear, this actually has nothing to do with the terminal. This has nothing to do with like the function console log or anything like that.
It's all WASM.
Yep. Essentially, the string's getting allocated in memory. Instead of getting the string passed back, we get a pointer to where that string lives. So we have to go find it and parse it out.
WASM doesn't have like shared function space. They have shared memory, and that's all the communication tools you have. Like that's it.
Right.
So you can only share like, here's an address to something. I hope you know what it is, because if you don't, you're going to do bad things. And that's on either side. Imagine how JavaScript is. They don't have like pointers in JavaScript, but you just kind of use it as JavaScript decides to use it.
Yeah, I'm just wondering if there's like a more generic, like, hey, run this code in a. I guess ChatGPT does, because I used a terminal in ChatGPT. I said reflect whatever is in the terminal, and it just gave me back what's in the terminal, and it was like doing it.
Just remember, ChatGPT is a very good liar.
I know. But it had a virtual box that I was communicating with. In the browser.
It's lying to you.
Yep.
It's telling you what it thinks that you should expect to see. It's not actually lying.
Well, no, it actually does run a virtual box.
No.
No, it does not.
It totally does.
No, it doesn't. It is literally guessing.
Regardless of whether ChatGPT runs a virtual box. Okay. We are going directly to memory. That was really the whole point. Okay, cool. So the next question is how are we exposing these functions from our Rust code? So that's where this little bit of glue comes in. So where did I go? So this assets file. This is where we're using these two files here. The Go server is using these two files to do the cargo build. Right, so there you can think of them as dependencies to that build process. The first is just this glue.rs file, and the code here. If we look at our compiler bit, is being appended here to the code we write. So basically what I'm doing is I'm saying I'm going to take this code, so this glue.rs file.
Oh, so you're slapping it right into the same file as their code.
Yeah, I'm taking
You're overriding stuff.
It's pretty nasty. But yeah, we're taking this code that we wrote. Somebody else wrote, because I don't know what I'm doing in Rust. And we slap this little bit of extra code onto it, and then we compile it with cargo build, right? And these are the macros that we need to define. And this is a library that we're using, that we're about to hop in and take a look at how it works. Like I alluded to earlier, it's macros all the way down. But at the end of the day, what we're doing that we care about is we're defining this console log function as an external function. And that's basically the API that we need to be able to expose that console log function to the browser. That's how it eventually calls it, right? Okay. So how does it work? And if you couldn't tell, these are essentially just the tokens that represent the macros that we want to make available in the browser. So print line, eprint line, things like that. Cool. The library. So some very nice human wrote this cargo crate. It is called custom print. And it has the macro tree that makes all of this possible. So what I'd like, if we have time, and again, feel free to ask questions, even if I can't answer them. But at the very bottom of this macro tree, we should be able to expand out and see where, at some point, standard out is getting hijacked. Because it has to happen somewhere in here. Right? So let's take a look. So now we're within the library, and basically what happens is we're calling this define macros function, which is defined in this library here. And it has this disgusting mess of syntax that I wish I never saw.
Did you write that or someone else?
No, somebody else wrote this. I'm not brave enough. From a high level, what it's doing, it's a little easier if we look at the actual function signature or macro signature. Yeah. It's taking a couple tokens. And I'm probably butchering like, the right words for these things. But it's taking a couple tokens. It's taking a macro, which concat is just a built-in macro to Rust, if I understand correctly, that concatenates things. And then it takes a expression? Maybe?
That's a type of a function.
Yeah, function signature, right?
Yeah.
It's a function with a I don't know the term, but it's a modifier or something. The extern C is.
That's a modifier.
It's a symbol marking.
Yeah, so this is a function signature, and then this is
Well, it's still part of the function signature because that's how to call the function. You have to know how to call the function in order to use it, so it's part of the function.
Cool. Okay, so we've got. I don't know what we're gonna call these tokens. A macro. And function signature. And here we've named them other things. So anyways, we'll get down to a little more sense. You have to kind of just squint at this part and go, okay. So we're defining some macros, and then here we're defining the implementation of those macros. It gets a little better when we go down and look at this part. So this is where each individual token gets expanded a little bit.
So just so we're clear, this is an improvement to you?
To what?
To what we were looking at before?
This is the implementation.
This is the implementation of it.
Uh-huh.
So
that seems more confusing to me.
Well, but those are the 6 lines he had to write in order to get.
This is what I wrote.
Which is far better than having to write all the other crap that somebody else already took care of.
Oh yeah, I don't mind using other code. That's not.
This is the code we're using.
He's just wanting to get to the WASM stuff.
This is the library we're using. So I will admit, I spent about 2 hours. Too long. About 2 hours. Trying to figure out how I could just go into this library and extract just the bits I wanted and put them directly in my code and have them work. And I got about 2 hours in and I gave up. So now I'm just going to walk you through the library and show you kind of what I figured out. And if anyone else wants to correct me, I would love that because I don't know what I'm talking about. But I did get it to work. And that's what counts at the end of the day. Cool. So
try doing a cargo expand on that.
No.
So expand will like all of this macro expansion stuff happens in the compiler.
Yeah.
Cargo expand runs all of the macro expansion.
So you can just look at these.
Spits back all of the raw Rust that has no macro.
That would have been super helpful.
Yeah, so you can do that to see what you're actually going to do.
Will it expand? Like, can you stop the tree of expansion? Like
it expands everything.
So even the standard library macros.
It expands everything.
There are ways you can put a marker to start and stop the expansion.
Oh,
Okay.
Well, last time I tried, I didn't see that.
So without it, it can be overwhelmed.
So I would recommend.
I can imagine.
To take those lines of code that you have, delete all of them, and just leave like the one print.
Right.
And then just like see where that comes.
The reason this is so hard to dive into is there's about 6 macros that we need to go through to get to the bottom one that's finally interacting with the standard libraries macro, where essentially the right is being hijacked. We'll look at that in just a second.
Hello world. Oh, yay!
The first thing that took me a long time to figure out was this is a pattern matching system. Again, knowing nothing about Rust. I'm like, what am I looking at? But yeah, so we're like pattern matching on these tokens, right? So here where we're passing in these tokens, that's essentially my understanding is we're pattern matching. These are the macros, right?
As an identifier.
Yeah, so it's saying when you try to call define macro with print as the first token, and then you have as and a name and all the other stuff. Anything with a dollar sign is like a variable, but then anything without the dollar sign is like exactly that token.
Like it'll exist in the output.
Right, so it's saying when you expand define macro with print as blah 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 blah, replace it all with this $crate define underscore print stuff.
Makes sense.
So, quick interjection.
Yeah.
If you want to understand macros, Rust for Rust Stations, Chapter 7. Also, I live streamed while I was reading Rust for Rust Stations, Chapter 7, and I put that in the chat.
Sweet.
So if you're familiar with regular expression find and replace, where you're doing groups, you can think of this as similar. It's a bit smarter than that, but it's still like you've got a capture group on the left and you've got a replacement on the right. That's essentially all that it's doing. And then
We're capturing this, we're replacing it with this, right? And in this case, it's another macro to go find and do it,
and again until it runs out or gives up.
And this syntax crate, that's this crate. Like,
yeah, so it's a weird thing that they have to do, because if you're using the macro in the crate, you have to use a different syntax than if you're using the macro from somebody else's crate.
Okay.
And the $crate is just a little magic thing that puts in either crate or the name of the crate you're referencing.
Oh, so you'd write it this way.
So
didn't care if you were creating something else?
Because you're trying to reference a macro that's in the current crate.
Okay.
And it's kind of like saying self for the crate.
Got it. And you can't omit it. You can't just do that.
You can, and it'll work, but only in the current crate, right? So if you did define macro in this file, it would work fine, but it would not work in another place. Because
Got it.
It needs to go to another crate to get to that.
Okay. Makes sense.
It's always a weird hack to get that to work right.
Actually, I think an example of that would be up here where we were referencing. Oh no, never mind. We're doing that here, even though it's not. Okay. Never mind. I don't know what I'm talking. All right. So define print. Go down and look at the define print line. That's the only one we've used so far. So print rs. So define print. Essentially just calls print like. This was an interesting syntax to me that I learned for the first time. This is the core package. So core library.
Okay, I got you.
Yeah, colon just is a way to say just go straight to the root and start looking things up that way.
So you can, correct me if I'm wrong, you can do standard like this. But sometimes you see it without the root.
Usually.
Right.
Usually
so
the root.
Okay. It'll try to look it up in the local scope, and that name could be overridden. If you do the double colon, it's just saying, no, this has to be the name of the crate. Just go look for the name of the crate. Right?
Got it. So we don't need to like. You can do that. Where you define it at the top of the file. In that case, you wouldn't prefix with the double colon, right?
Right. Usually in your own code, you won't use the prefix because it's your own code. You would know if you overrode standard in your own code. But when you're writing a macro where the generated code is going to show up in somebody else's crate, you don't know what crazy thing they did. So you do the absolute stuff.
Okay, cool. And the difference between core and standard, I kind of looked this up. My understanding is the core is a smaller.
There are.
So when you include it, you don't get crap in your
dynamic allocation.
Core should be able to run on everything, in theory, including embedded and weird systems like WASM.
Okay.
No floating points.
Like you're compiling for a remote control or something.
No heat. Right.
So core is very but it is all of the things that you theoretically need for some of the basic writing machinery to work.
Got it. So like for our microcontroller, we just core.
Yeah, if it's in core, you can still use it in a microcontroller.
So this is where some of the magic happens, right? We're going to go down a few more macros. But this is where we're hijacking this. I think this is write a macro. Everything I've looked at has been macros. It's macros all the way down. Okay. As far as I can tell, this is
Core, right? There is a
right should just be a function.
Let's go find it. Core, right?
No, that's a macro too.
It's not standard, right? It's this guy, right? Macro rules are
still a macro.
writer, a format string, and a list of arguments.
We can begin this with, it's all macros all the way down.
Yes. This is why I where is the thing happening? But this is where we basically go from crap we have to write or our library has to write and passing off the writing mechanism to the standard core library. So this is where we're connecting. And now when our users use that macro, we're able to capture the output. Awesome.
Because you're passing in a formatter, and then in this case you can pass in whatever the heck formatter you want.
When you say formatter, you're talking about the concat?
You're passing a writer.
Yeah.
Right? So if you look at the first argument here. Right, in the docs.
Yep.
The first argument is an
expression.
Right, and the writer you can just make up a new WASM writer and feed it to that. So you don't need to care about the implementation of formatting, which is quite nice.
So yeah. Now I'm a little more confused after what you said. Yeah. Okay. So this is a macro. We figured that out.
The name of a macro.
It's the name of a macro. Yeah, it's like passing the name of a function. Passing the name of a macro.
So if you look at print like.
Yeah. Let's do that.
Wow, how many macros are we down so far? This 4?
I think 4. So we want to look at.
Looks like it's in print like does.
Right there.
Okay, so that dollar macro was where we were putting right. So now we've got to go down to another macro layer to the.
Is this a common convention, by the way? Like, I noticed this is how this guy's writing everything. Like there's the name of a function and then like an underscore implementation.
In macros, it's really hard to do things like looping and conditionals and whatever. And so the way that you do it is you make another macro and then you do more pattern matching. So yes, this is common when it comes to macros.
Because I couldn't decipher why this is broken up.
Yeah,
Impl doesn't tell me much.
I say writing macro is pretty dang uncommon for most people using Rasta.
Yes.
You just use the built-ins.
Yeah, most people just use the built-ins and don't ever really have to write the macro.
Yeah.
There are specific situations like this one where they can be super useful, or when you're doing something really repetitive and then my macro, why is it? Most people don't get really macros.
I think it's some really entertaining stuff where you have a macro defining another macro.
Some of us would use the word entertaining.
Well, he did.
Some of us would use other words. Cool, yeah. So we got down into print write. Print-like implementation, and this is where we call the macro rules. This is the built-in. Make a new macro, right? And now we're finally making a dynamic macro.
So now we're defining the print line macro.
Yeah.
Now it's getting passed off to create the create write macro.
And we're passing it in that core right here.
What exactly is a dynamic macro?
Well, so rather than hard coding, yeah. So for example, if you look at this one, right, we're creating a new macro called define print-like implementation. And we've hard coded this. This is the first one we ran into in this library where we're using variable name as the name of the macro. Pure insanity to me.
Define.rs real quick.
Define.rs, yeah.
You get a tab open still.
Thank you.
Yeah, so you see this huge list of all of those different versions of things. Like, for the most part, they all do the same thing. There's little variations as to the way that they work, but basically they all take a format string and they all take a whole bunch of arguments and then they do something with it. And so the implementation of all of these is almost identical, and then there's just some weird little quirk about the way that they're all different. And so instead of having to implement these like 20 or whatever 30 different things it is, they're using macros to try to reduce the duplication here.
Yeah, and this is a specific set of things that we in our code right here are allowed to use. Like if it wasn't defined in the set, we wouldn't be allowed to to write it.
It's easy to visualize what's going on though. Even though it's not dry at all, right? It's like then we just see exactly. I don't know.
It is definitely hidden under many layers of confusion. Writing this kind of code can be quite.
I can only imagine reading it was pretty rough.
Let us all take a moment to consider the kernel's prayer.
Do you want to recite it for?
Well, you were the one that came up with it.
I can't remember.
Well, one of them is definitely flat is better than Nestle. So he came up with a Zen of Python, and then I dubbed it the kernel's prayer.
Well, that was a separate tweet.
He said, lead us not into the callbacks, but forever let us await our salvation.
It was the whole thing.
Programmer terminology. It was hilarious. It was great.
Can change the code. We can change.
Yeah. So anyways, that's how the library kind of works. If you're really curious, you're more than welcome. It's the custom dash print. To take a look at that. What I'm much more qualified to answer questions on is anything else. Any other part of the system, because once I realized I could write these 6 lines and get those macros working, I was a very happy person. Cool. Yeah, we're coming up on almost 8 o'clock. So yeah, any questions about Rust, about the playground, web workers, WebAssembly?
Is there any protections for any malicious code people could write on this?
So that's actually a great question. That's kind of the reason for doing it this way. So we don't have any Rust courses on BootDev, and I'm sure you're all thankful because I don't know what the hell I'm doing. But we do have Go courses, and I was concerned with the possibility of people writing malicious code, right, that I'm running on my own servers. And I could go through the hassle of really securing the back end, making sure that that VM can make network calls and things like that.
But you're not running the code in the back end. You're only compiling it.
That's my point. So that's why I decided to do it that way, just extra safe. What's that? Yeah. So the Rust one is more dangerous than the Go one.
You can run code in the macro to remove files.
Yeah.
Can I try it?
You can try it. It's running in a
Macros?
Commit more code that's then inserted to that spot.
They can't actually it's not really loading.
Yeah, they're only manipulating the abstract web texture.
Is there no maliciously do anything at compile time in Rust? Because I thought in C.
I've seen macros. There are macros that read files from the file system and embed them in the binary.
Yeah, so there are those. That's something you might want to check about.
You can definitely do this.
But so you can run one.
Yeah.
Write one that does that.
No, you can't.
Definitely.
But you could just use it, right? Because I allowed you.
No, not the macro. Procedural macro. You can run procedural macros.
Yeah, but you have to actually install the procedural macro, so he's not letting you actually install it.
You couldn't write one in here.
No, because you have to have it in a separate crate in a separate file with the right cargo.com structure in there before it'll actually.
Yeah, but he's just compiling.
Right, but you only give him one file, and he puts it all into one Rust file.
And it's expecting it to be binary.
Right.
Not a library.
Right, and you have.
Well, you don't get access to cargo.com. So if you want to add something there.
And you also don't have the other Rust file that you have to have in order, because Rust has to compile the procedural macro and then run it.
But you can write modules. You can have a submodule on here to define.
Yeah, but that's not great. There is no syntax for a subcrate.
Could you have tests? Could you have tests for that macro? In response.
He's not running tests. Building.
Oh, he's not running. He's not running pilot.
Yeah.
All we have to do is get it to compile, and then we can run the code.
I welcome anyone try to break the server. It would be very fun. If you do, please let me know. But no, like to answer the question, that's why I did it this way. And in Go, I was very certain that there was nothing that you could do that would break anything. But it's really nice to have the peace of mind that all I'm doing is compiling your code, because obviously students do all sorts of nasty things, and it's not like everyone that signs up on Blvd is a student. There are people that want to test the limits of the system. To answer your question, that's mostly why we compile.
Do we have the Rust compiler built in WASM yet? Could you just, let them download the Rust compiler in the browser I
don't know. I know in Go I could do that. I haven't done it. I'm actually just using the normal just Go build on my server. But there is a way to compile Go code in the browser. I'm mostly concerned with like what's actually faster. I haven't tested either way.
The server's going to be faster. Running native GPU code. That's the one that's faster.
Well, but you might be able to avoid the network call, right? What? Maybe.
The network call is not the problem here.
Hello World. Well, keep in mind, Hello World and Go is.
Well, I'm just saying. I tried to compile Go code in the browser yet, but it sounds fun.
No, it does.
But you can compile back in Go on the front end. Is that what you're saying?
What?
You can compile back in Go on the front end on the browser.
Well, so JavaScript is a programming language. It is Turing complete. It can do anything that any other programming language can do. So therefore, it can compile into bytecode any programming language if you write the compiler. WASM is a bytecode implementation that can run through LLVM, which is basically the Babel. What's the Babel thing called? The thing that translates any language to any language. The Babelfish. Yeah. So LLVM is the Babelfish of all C and bytecode like languages. So anything. So you could, if you can compile the Rust compiler, which you can, then you can compile it to WebAssembly, which means that you can put it in the browser, but it'll probably be several dozen megabytes.
So there is a production
But would the sandbox stop like malicious things from happening? From that?
I mean,
it's not necessarily malicious.
To do all kinds of things like read files directly, right? That you cannot do in WebAssembly.
Yeah, that's exactly.
You'll
I
find
can't read
files.
a file when I understand.
Well, it's compiling not making a bunch of system calls. It might be trying to read files. That's super easy to emulate. I mean, everything has a virtual file system. Your file system has a virtual file system. I heard you like virtual file systems. You file dog.
So one of the first WASM demos that I saw live at the UJUG meetup, actually, a couple of years ago, they actually had an entire like shell, tool chain, everything, and he literally live compiled C code using GCC, not LLVM. And he had two terminal windows on the left, and he had one on the right, and the result was on the left, and then he was able to interact with the system that he just created in the lower left one. And it's possible people have been doing stuff with it. It may not be practical, which may not be why nobody does it like fairly commonly. But it's definitely possible.
It's very practical. You can get so much money from doing stuff like that. Like not morally.
So the way Python works on Blvd is the entire interpreter is written in WebAssembly. And you download the Python interpreter and run your code. And it takes about a second to download it. So it's like I mean it's been optimized. The package we're using iodide. But I do know that there's a fairly well supported project for compiling Go code in the browser. Again, I just haven't used it. So I don't know.
I'm curious how the sandbox works with the Chrome. That's very interesting. So
It's containers all the way down. So you have an operating system process. You have jails. You have virtual machines. You have just-in-time compilers. So Chrome doesn't have to let anything execute that it doesn't want to execute because it is its own compiler and memory manager and all the things. So Chrome is essentially an operating system. It provides file system APIs, network APIs.
Also, very importantly, WASM doesn't have any of the interfaces that you would like associate with like a file system. like he just did with like input output, you would have to do with everything else. And people have, because we're nerds and we do that. But you have to do it all of yourself. It doesn't have APIs for like storage. It doesn't have APIs for input output. It doesn't have network APIs. None of it. The browser doesn't provide anything. The spec doesn't provide anything. As a matter of fact, you can't even run it on a server and have it do anything without doing all of the extra stuff that people are starting to do with like WASM, which is WebAssembly server interface, to provide some of those, but in a sandbox like your Android or iOS jail shell or the app kind of a thing. So like there's some standards that are coming to fruition, but most of it doesn't exist. And so unless you're providing it, and then again, you can provide it, but it's all fake and stuck in this tiny box. So the file system is still in the WASM engine in your browser, and it's just bytes in memory. There's no like mapping to local storage unless you can do it with JavaScript, and even that's like locked down to all get. So you're interacting in this sandbox with another sandbox and faking everything.
Yeah, so what does it do here if you try to write to a file?
You can't.
It
Yeah.
would fail.
But you can't even import the std colon one FS.
Yeah, so if you hadn't used the glue code, you'd fail at compile time. I did that.
I may have tried it.
The WASM version.
I was like, oh, this is great. I'll just use the print line macro, and it'll probably just hijack console log, which I'll hijack, and that'll be
Do you
fine.
have anything in the standard library available?
No, so yeah, like I said, if you Google, like, how do I print to the console in Rust WebAssembly, you use a different syntax. You can't just use the print line macro,
Well, right, but like,
which is
do you have
not
like
useful.
std containers hash map available?
Yeah, I've compiled. I've used hatch maps. in my-
Wait, sorry, you said like data structures in the standard library?
Yeah.
I'm sure that's fine. I'd be surprised if it wasn't. Because we're using tons of standard library and core stuff in this library that's being compiled down to WebAssembly. So I can't see how it wouldn't work.
Really? Your imagination is not that big?
You can actually use a lot of prints.
As long as, I mean, it's like Todd said, I would imagine the breaking points are at the edges, right? Where you start to touch file system and things like that.
Basically, any I/O you have to fake.
Yeah, it's like JavaScript, right? JavaScript doesn't have a way to open a file and write it. You could write an open file function and you could have it operate on some data structure you created, but that's, so Node got to create all the I/O stuff from scratch, which was probably helpful because you got to write it in a different way.
Yeah.
All the async stuff as opposed to if you had some sort of existing synchronous file methods you had to implement.
Right.
I was reading this sort of related in South Korea. They have this software you have to have installed to access government or banking websites, and you have to have it installed or else like it will not. Your bank will not work. Like, and so it's a server that runs on your. It's like a local server that runs on your machine and communicates with the bank somehow. And it's like it takes all the data off your computer, like reads it. And it's crazy. It's like wonder like where everything because Chrome is big and Chrome does. I know my anti. Like one of my anti-Google friends is like, yeah, like Chrome takes a gigabyte of your data just sitting on your computer, in a month, and it's like, where is it getting all this data? What is it doing? So it's like we think like Chrome's safe, and then it's like, well, that's where everything's happening. So it's like, I don't know. It's just interesting to think about that too.
Yep. Cool. Well, that's pretty much everything I had to talk about. I learned a lot. I hope someone learned something. But yeah, that's it. Thanks for listening to my TED Talk. Am I good to close this?
Yeah, you are.
Jitsi?
Huh?
Kill the stream? Cool.
We're offline. Thank goodness.
We're never offline.
How many people tune in online?
So I actually just rebooted the whole system. So now Utah Rust has its own Twitch channel rather than piggybacking off of mine. So approximately, I don't know, maybe one person tuned in online. But in the past, we've gotten 5 or 6. So as the reboot takes hold, we will get more and more. And this presentation, just by its title alone, is going to get hundreds of views. And if people like the content, then it will get thousands of views.
So we're on Twitch.
Twitch and YouTube.
So we'll hopefully have a SWAT team here pretty soon.
Speaking of swatting, so for everybody that tuned in online, thank you very much. For everybody, whether you're online or not online, I want to give a big thank you to Vivint for providing us a location to meet, particularly to Jeff for making sure that we have goodies to eat. That's this guy over here, and to Lane for coming to roast our meetup while he presents on WebAssembly. It's good because I didn't have to do it this time because you did it. So, and then of course, thank all of you for being here and helping us build this nice Rust community. So, with that all out of the way, if you're online, consider like, sub, follow if you wanted. There's also some other channels that get hosted here, including Utah Stack.js and my own channel where I do a bunch of live coding. And actually, this is a question I wanted to have. Does anybody else in here do streaming? Do live coding streaming? Jojo Bite? I mean, Jordan? I mean,
He knows.
Proton PM me? I mean, sorry, I didn't know. I don't know what to call you anymore.
Don't worry about it.
Right. Oh, I'm so confused.
We will call him Pete.
Oh, Pete. Yes. That works great. Okay. Anybody else? Because we can set up to host. It's called host channel. So basically, if you do a Twitch stream, then we can add you to the list so that when if you're streaming, then because the Rust channel does nothing for most of the month, then it would just chill anyway. But yeah, there's a Discord to join. If you haven't joined the Discord, you should join the Discord. I'll go ahead and post a link to the Discord in the Discord. No, that's not what I'm going to do. Because we have a sandbox and a virtual file system and a macro.
One macro?
Just
Lame.
one. It generates all the others.
Macro, you rule them all.
You're just saying jargon, aren't you?
Just saying jargon. I would never. Oh, actually, there's already a link to, if you check on YouTube or on Twitch for Utah Rust, you'll see in the comments that there's a link to the Discord. So if you want to join the Discord. So order of business. So Nate is taking over the meetup. I'm trying to get things sorted out because I want the online stuff to still continue to happen because I think that it actually does help people because we get thousands of views on some of the videos and dozens of views on others. And
Tens of people watching.
But I don't know exactly what I'm doing right now. But the meetups are switching back, like Nate said, back to second Thursday because that works better for him. And so the meetup group, I think I set it to something like $10 a year, and that basically my main goal there is just to call out the people that don't actually come anymore, that have moved away. So that instead of showing that we have 700 inactive members, it shows that we have 50 active members. And then, if there's any change left over from that, I'm just going to pocket it, take my wife out to dinner, maybe take Jeff out to dinner, something like that. But it'll potentially go towards the meetup cost. And if Nate takes over fully and completely, then he'll do it however he wants to do it. But I think it's good for the meetup to actually not have 600,000 inactive members. Just a little algorithm told me that.
$10 whole now.
So let's just go around real quick. We normally do this at the beginning, but we didn't, so we can do it here at the end. Let's just go around and introduce ourselves. And if you need a pseudonym, just cover your eyes while you speak. Not naming names, Pete. No. So I'm AJ. I was Rust curious, but I found myself a little zig. So I'm moving on from that. What? And then right here we have
Jake.
Jake.
Heavy on the cloud infrastructure space right now.
I'm Matt. I'm an SRE, dabble in Rust in my free time.
And you don't have to speak of this thing. You can speak of the people that are here. They're the ones that are important.
Hi, everybody. I'm Kyle. I'm around Rust.
I'm PJ. I play around Rust too.
I'm Redalia. I don't know anything about Rust, but I want to learn.
It's a cute little crab. You can get the plushie or the sticker. I've got one.
Well, I'm planning to get both.
There.
Good.
Really big one.
Oh my gosh. My name's Alfie, and I'm also just curious about Rust.
Jordan, yeah, I'm curious about Rust. I dabble in Rust, JavaScript, Sig, all sorts of stuff.
Fun.
I'm Matt. I work here at Vivint too. I don't actually work in Rust, but I'd love to try and convince someone to pay me for it.
We do need to convince.
They're not here. So, I mean, I guess Jeff's kind of my boss now. I don't know. He's somewhere in there, but.
He seems uncomfortable with that statement.
I don't think that's true in meetings.
Yeah.
I'm Jesse. I was curious. I've been playing around with it for like 2 or 3 weeks. Yeah.
So what do you think as a 2-3 weeker?
Where
are you coming from?
Mostly like JavaScript background. Mostly.
So Rust is probably a lot better.
Rust is a lot better, yes.
Yeah. JavaScript's rough.
You're not confusing at all.
Feel you.
No, it's
Yeah.
Oh, Spencer. I was only kicked out 5 times last year.
Record, really. I'm Todd. I dabble in Rust when it is appropriate in my mind.
I'm Jeff. Work here, mostly management though these days, so not really useful. But I've written characters of production Rust code at this point. So.
Characters?
Yeah, I updated a few logging lines. It's filed, so I'm again, mid-level.
Macro expert.
Literally dozens of characters.
That's pretty good. That's more than most people.
I'm still Lane. I've written a Rust playground, and I also learned how to write a for loop today. There was no for in the loop.
It wasn't a
It was just a loop.
It
was just a loop. So I'm still curious on Rust, but I've spent basically 0 time learning. So.
All right. So wait. So how many people have gotten paid to write even a character of Rust? All right.
Technically.
Okay. So we got 1, 2, 3, 4. Is that 4? Actually, that's 5. Because you know what? Have any of you ever heard of Sonos?
Mm-hmm.
Yes.
Have you listened to their radio station?
No.
Okay, well, if you listen to the radio station and you hear an ad, the reason the ad mixes so smoothly between the music, I did that. That's Rust.
So you're going to hell is what you're saying.
Hey, maybe a little bit. I repented. I'm back to go, and
he just made them function better.
He's in and out.
No, it actually, I'd love to talk about that sometime. I probably can talk about it without going into too much proprietary stuff.
We should talk about it before you leave us forever.
I'm not going to leave forever. I'm going to come back when Lane's giving a presentation, or when Nate's giving a presentation, or somebody that I have a crush on is giving a presentation.
Jake.
Program with crush. I do have a wife. So.
Don't want to make her jealous.
There's a lot of people that hasn't stopped.
Yeah, that's true. All right. Anyway,
Just gonna leave that
so
one there.
I'm gonna I will now turn off the stream, and then we can just do whatever, and it'll be off the record.